Everyone, I am Lyza Maraño from BSED English 3A, and I'll be discussing the quantitative statistical treatment of data test of significance testing differences between groups t-tests. Here is the lesson objectives. At the end of the lesson, the students are expected to define the dependent t-test, identify the differences of paired t-test, independent t-test, and one sample t-test, and use the correct formula for t-test. Let us define what is a parametric. Parametric is a type of equation that employs an independent variable called a parameter. It is often denoted by t, in which dependent variables are defined as a continuous functions of the parameter and are not on another existing variable. Parametric statistical test is used to distribute the data normally. These types of test includes the t-test, z-test, and ANOVA test, in which assumes the data is from a normal distribution. T-test. A t-test it is a statistical test that is used to compare the means of two groups. It is often used in hypothesis testing to determine whether a process or a treatment has an effect on the population of interest, or whether two groups are different from one another. The t-value, or the test statistic, it is calculated for the present data and compared with the t-value at a specific level of significance for concerning degrees of freedom or accepting or rejecting the null hypothesis. The degree of freedom is calculated by subtracting one observation from the number of observations. It is used to check the t-value in the distribution table. Sometimes the t-test is used to compare the means of two related samples. When the sample size is small and the population variance is unknown, in this kind of situation, it is known as the paired t-test. For example, you want to compare if the people of one country are taller than the people from one another. Just like America and Philippines, if we would compare the height of the people from America, we can see that the people in America is more taller than the people from the Philippines. And another example is comparing a person, if a person who is more active while watching happy movies than watching sad movies. It is a type of inferential statistic used to study if there is a statistical difference between two groups. Mathematically, it established the problem by assuming that the means of two distributions are equal. If the t-test reject the null hypothesis, it indicates that the groups are highly probably different. When to use t-test? A t-test can only be used when comparing the means of two groups, or also known as a pair wise comparison. This test should be implemented when the groups are have only 20 to 30 samples, and if you want to compare or examine more than two groups or larger sample sizes, there are other t-tests that is more accurate than t-tests, such as z-test, chi-square test, f-test, or if you want to do a multiple pairwise comparisons, you can use ANOVA t-test or test. Test is a parametric test of difference, meaning that it makes the same assumptions about your data as other parametric tests. The t-test assumes that your data are independent, are approximately normally distributed, and have a similar amount of variance within each group being compared. And if your data do not fit these assumptions, you can try to You can try a non-parametric alternative to the t-test, kagaya ng Wilcoxon signed rank test for data with unequal variances. For example, you are comparing two means. Use a t-test when you want to compare the means of two groups to determine if they are significantly different. This applies to both independent samples, for example, two groups of different people, and the paired samples. It for this example is the same group of people tested before and after an intervention. You can also use the small sample sizes. The t-tests are particularly useful for small sample sizes, typically less than 30 per group. Just like what I have said earlier, if your sample size is larger, other tests, you can use ANOVA. The result might be more appropriate. Testing assumptions. Use a t-test when your data meets the following assumptions. The data is continuous. Example, the height, weight, test scores. The data is approximately normally distributed. The variances of two groups are equal for independent two sample t-tests. The observations are dependent of each other. Is what type of t-test should I use? Um, when choosing a t-test, we have to consider two things: whether the group being compared come from a single population or two different populations, and whether you want whether you want to test the difference in a specific direction. We also have a different t-test: the independent two-sample t-test, the paired sample t-test, and one-sample t-test. The independent sample t-test is comparing the means of two independent groups, for example, Group A and Group B. While the paired sample t-test, it is comparing the means of two related groups. For example, pre-test versus post-test scores for the same group. And the one sample t-test, it is comparing the mean of a single group to a known value or population mean. Tailed or two-tailed test. If you want or you care whether the two samples population are different from one another, you have to perform a two-tailed t-test. And if you want whether one population mean is greater than or less than the other, you should perform a one-tailed t-test. I have here the example of paired t-test, independent t-test, and one sample t-test using computation and the formula that used. Okay, a paired t-test or dependent t-test. After a teacher, after seeing the poor mathematics scores of the class, decides to conduct special tutoring for the subject. The test was out of 10. She then compares the before and after scores of the students and the result outcome as follows, as you can see on your screen. And the alpha is to be assumed as 0.5, and the aim is to find whether the special tutoring was effective or not. Step 1. Define the null and alternative hypothesis. The hypothesis can be written as HO. It means the null hypothesis, the mean before and after the special tutoring is equal, meaning the course did not make any difference. Alternative hypothesis before is equals to alternative hypothesis after. The H1 means the alternative hypothesis mean before and after the course is different, meaning the course did not make some difference. For step 2, degrees of freedom. The degrees of freedom for dependent sample t-test, df is equals to n minus 1. df means degrees of freedom is the total number of observations minus 1. So in our case, degrees of freedom is equals to 10, which is the number of the quiz from the teacher minus 1. So the degrees of freedom is equals to 9. We have a rule that if the t is less than negative 2.2622 or greater than 2.622, we have to reject the null. Step 4. Calculate the test statistics. The formula for calculating the t is on your screen. T is equals to xt over sd divide the root of the sample size. X is where x bar d is the means of difference. SD is the standard deviation divided by the root of the sample size. For the difference, we will add one more column in the table as you can see on the screen, we have before, after, difference, after, before. So 7 before, the score is 7 before, and then after 9, and the difference is 2. 6 before, after is 10, and the difference is 4, and as like the others. Now for the numerator, we have to find the mean of the differences, which is 10. So we have the x bar d, 2 plus 4 plus 2 plus 1 plus 3 minus 1 plus 2 plus 1 plus 3 plus 0 over 10 is equals to 1.7. If you are wondering kung saan nanggaling yung mga 2, 4, it came from the differences before and after the test score of the students. We have for the standard deviation, we have the formula. It can be calculated as follows. Standard deviation is equals to data points, x squared minus data points over n divide n minus 1 is equals to 49 minus 17 squared divide 10 over 9 is equals to 1.49. Now we calculated it as t is equals to 1.7 from the means of the differences over 1.49 from the standard deviation divided by the square root of 10 is equals 3.61. So for step 5, state the result according to our decision rule, wherein we have to reject the null hypothesis if the t is less than negative 2.2622 or greater than 2.2622. So our t is greater than 2.622. So we reject the null hypothesis. The mean before and after the special tutoring is equal, meaning the course did not make any difference. For step 6, we can state that the special tutoring helped the students score more than the before tutoring. So for our conclusion, we can say that AT test, it is a method to check if there is a real difference between the two groups. It compares the average mean scores of the groups to see if they are significantly differences or they are significantly different. Um, this also helps the researchers like us to find out if the differences they see in the results are likely caused by something real or just by chance. The importance of qualitative statistical treatment, particularly the use of the test for testing differences between groups, lies in its ability to provide a reliable evidence and research. AT test helps to determine if the differences observed between two groups are real or simply due to chance, which is crucial for drawing valid conclusions. This kind of method also ensures that decisions and insights are based on measurable data, making studies more objective and trustworthy. That is all. Thank you.